So yeah, I'm going to talk to you about something, am I crackly? That's okay. About something you should be aware of. We try and tell this talk in like a really light-hearted way, but it's something quite serious. We're talking about security vulnerabilities here. We're talking about open source and how the two things kind of interact with each other. So before I get started, yeah, I'm Josh. I'm Josh J on Twitter. I work at Snyk, and of course, like all of you, I'm sure, I love open source. So the positive message is open source is awesome. If we look at Node.js, which is probably where most of you are getting your packages from, and this is really outdated information, but they just published a blog post the once. There were 360,000 packages with 1 billion downloads per week and 73,000 publishers. And I don't even know what order of magnitude we're at now, but like that was back in 2016. I think only things have kind of sped up since then. So first of all, like, how many of you think, like, let's think about the code base you contribute to the most commonly. Do you know how many dependencies you've got in it? Like would it be 10, 100, 1,000? Do you have an idea of how many you've got? Have a think. So this is Express, and I just ran it on this little website that you can go to in your browser, anarcha.com, and it's starting to traverse the tree. So like you can see here that first of all got the top level dependencies. I think there were like 16, but it ended up with 42 in total because each dependency might have a few that it relies on. This is a relatively small dependency tree. You can get much bigger ones. And if you think that Express is just one of your dependencies, you've probably got quite a lot if each dependency in turn is bringing in 42 or 41 other dependencies. And I think I use this website because you can also see over here the maintainers list. Again, a relatively small number of maintainers for a package like Express, but you can imagine how many maintainers are kind of contributing lines of code that you are pulling in. And if you're using Semver, which is the default, it's getting upgrades for free, and you don't actually vet those upgrades. So you don't necessarily know what code you're running. That's the reality of the situation, but we get all these speed boosts so we can work really productively. So we had a look back in 2016 when this talk was first put together, and at that time 14% of NPM packages were carrying known vulnerabilities, and that meant that 76% of our users who are using our software were having at least one vulnerability in their applications. So, you know, more than likely you already have at least one vulnerability, sometimes many. So open source is awesome, but each dependency is a security risk. We can look at the number of data breaches that are happening over time. This is from a health organization, HIPAA, which is actually one of the more secure kind of bodies. And they were looking at health, particularly healthcare breaches. And I think I just wanted to illustrate that the pattern is an upward trend. So over time, this is just becoming more of an important thing. We need to take it seriously. And I'm well aware that, like, as developers, we've got so many things we need to deal with. We've got testing, we've got usability concerns and accessibility, we've got cross-browser testing, we've got, I don't know, so many other things that are considered really important, responsive design, and the list goes on. This is one more to add to your arsenal of things you have to care about daily. So I'm sorry to overburden you, but it's the reality of the situation. And what was this one? This was a, this is to do with cost. So this graph here was on the Forbes website and was showing that global averages in 2018 were at $3.86 million for the average kind of data breach. So we're talking about real-term money for companies here. I think GDPR kind of changed the game entirely because now, if you're complying with GDPR, it's only up to 10%, I think, of your revenue for a year. Otherwise, it's 20%. So it's a lot. For lots of companies, that might just be the thing that breaks the camel's back. So we want to take this stuff seriously. So first of all, how do you protect yourself is probably a question you want to ask. And how can you learn about these vulnerabilities? So I'm going to switch over to my terminal and editor here. I've got a code base that I've cloned down to my computer. It's called goof. I didn't make this repo, so I don't know why it's called goof, but we always talk about the goof app. If you go and run it and visit it in your browser, it's just a simple to-do app. You can do things like type in go to JS monthly and add that as a to-do item. And it's just really a hello world application, but we've made it deliberately vulnerable so that we can kind of show you some real world examples. I'm actually going to start at this about page, this beautifully styled link at the bottom there, and go to the bestest to-do app ever. And we're going to start with our first vulnerability here. Now, here's something I prepared earlier. I've already scanned this dependency tree with Snyk. So you can see here our dependency tree, and you can see where there's high, medium, and low vulnerabilities discovered in that dependency tree. If I just search for MS, here we go. There is, not this one, sorry, there's actually multiple MS vulnerabilities by this point in time. It would help if I was typing the right command. I think it's, sorry, one sec. It's ST, that's what I want. Yep, sorry about that. Here we go, directory traversal. So this is a pretty common pattern. So hackers have a whole kind of plethora of different ways that they try to get into websites. Now, if it's a known vulnerability, and this is known because it's documented here, then they can actually be quite specific and write targeted attacks. But if it's an unknown vulnerability, they probably just try to do things that normally happen inside of operating systems and web servers. So directory traversal is where you want to kind of traverse up the chain and get into somewhere you're not supposed to be. So we can see here some information about this particular bug, and either I'm offline or the website's down. I did tell everyone not to break the website while I was here. Okay, the Wi-Fi went down. No, we're back online. Okay, let's see. It's our website that's down? There will be panic in the office right now. I can't believe it. Well, they obviously saw me coming and thought, I know what I'm going to do. We'll see. We'll see if it comes back up. That's terrible. So, it's all right. I don't need the website right now. So the first thing I'm going to try and do is just do a .. on this path here. And the browser is clever enough to know that I'm trying to go one level up, and it just takes me to a URL one above. So it's at this point we can't actually use our browser anymore to try and get up one directory. We need to switch over to curling things, because curl does what you ask it to do quite commonly. So we can first of all just do a really simple thing and curl the about page, and we'll see some HTML there. And can everyone see that? Is that big enough? Yep. So then if we do the next one and curl at /public, we get an index page. So this ST dependency, by default when you've used it, and it's basically like if you've ever used Express Static, it's basically the same thing as that. But by the defaults of the package, it will actually show you directory listing pages. So you need to turn off those defaults. Now, this one isn't considered a vulnerability because it's documented. It's part of what the package says it does, and you can configure it. So the first thing to do is make sure you've read your documentation when you're using a package and turn off things like this if you don't want them. Really, this is an insecure pattern. We wouldn't want to see this by default. We would want this to be turned on explicitly by the user. Now what we're going to try and do is curl with some .. Now I said before the browser was clever enough not to curl the page, but when you curl it, it's just going to send that URL straight through to the server and see what happens. What do people think is going to happen here? Any guesses? Yeah, well that's what you sort of expect given this is like a security vulnerability talk, but actually it's clever enough to figure out that dot dot slash shouldn't be allowed, and it's just showing up to the home page. So it's up for you. Is it back up for me? That's the question. No. It wouldn't surprise me if I've been messing about with my host files, but it was working a second ago. It's okay, I don't need to use the website. If I find that I need to, I'll figure it out. But the website's up, everyone. We can breathe out, but I'm going to make do with a dodgy setup here. Okay, so the next one is what a hacker might do. Now, what's the difference if I just compare? Can you see the difference there between the last one and the current one? What's the difference between these two lines? Can anyone kind of work out what they're seeing there? Let me make it even bigger. So we're looking at this compared to this. Yeah, exactly. So we're using URL encoding to send what's a valid URL, and this would translate to dot dot slash, but it's URL encoded. So let's see what happens when we do that. So we're actually fine. It's done the URL encoding, done the URL decoding, and it's still protecting it, so it's still showing the home page. Oh, you're right. So no, that isn't fine. There we go. I was thinking, did they do one more level of escaping? So like packages should try and prevent people from encoding things and getting through back doors like this. But this one is pinned to an old version. This is version 1. But check through your package JSON. You may well be still on the 1.x branch of some packages. And so it has been fixed in later versions, but depending on what major version you're pinned to, you might still be vulnerable. So here we've managed to get up to the this is my computer telling me what's in my index of, these are all my sites actually, so you can see I used to work for Mendeley, I now work for Snyk. I have my little support folder there, my personal stuff there. We're on my computer here, we're outside of the web server. And so we just need to do a few more of these. So if I take that last one here and just copy that and put a few more %2es on the end, we can get all the way up to the root level of my computer. Then all we need to do is just do etc/password. Is it spelled like that? There we go. So we can load any file that we want this way. We're on the computer. So anything that's on disk, like, I don't know, are your secrets on disk? Maybe they are, maybe they're not. Probably something you don't want someone to see is on disk, and your source code, for example. So they can start with a bit of source code and start to see, oh, now how could I get in further? Do I get DB access at this layer? You know, so that's obviously something you don't want to do. So I would like to load this page. Don't know what to do about this. Okay, I'm going to carry on. So that was the ST exploits that you saw there. The fix obviously is to upgrade to a later version. There is a later version available, and that's just going to get rid of that vulnerability. So one of the things you can do is just make sure your dependencies are up to date, and people are normally, if a package is well maintained, they're going to be trying to fix vulnerabilities as they go along. Not all packages are equally created. Sometimes they are unmaintained, and you'll just be vulnerable forevermore. Because no one's fixing that vulnerability. The next one I was going to show was to do with the database. There's a little spoiler. So we've got our database here, and if I show you how it's configured, because this is a particularly vulnerable app, we've decided to use a buffer as the schema for our to-do app. So buffers, you wouldn't normally store strings using a buffer. It's a bit overkill, but for files and things like that, a buffer is a way to be able to stream things into your website. It's really a bit of memory. So that's what buffer is. You don't need to know too much about them, except that anytime you see a buffer, your ear should go like that. It should be like, is there a vulnerability here? So I'll show you why you should be worried. First of all, I'm going to open up my network tab. And I'm just going to post something else. What else is on our to-dos today, eat more pizza. So when we do that, we can see here there's a create endpoint that got pinged with a post request, and the data that got sent was just content, eat more pizza as form data. Pretty simple. So we're going to now do mon1. I think this is it. There we go. So I'm just showing you, first of all, we're going to switch over to using the HTTP library because it's got this nice color coding and it's going to be more useful for seeing the headers. And that's just showing you the headers there for the home page. We're now going to put content equals buy beer and post that up to this create endpoint. So that worked for us, and if we maybe make this a little bit smaller and refresh the page, buy beer. So we were able to curl the same endpoint and post up the same data. Then we're going to go one further. Now, because this is an Express server, and if you've ever played around with Express, you know it's pretty out of the box. It's pretty lenient about how you push your data up to your server. If it's, I think it's to do with the middleware that you've got and what you've accepted, but most people out of the box are just configuring this stuff to accept JSON because it's super easy to post form data in JSON format. So now we're going to do a JSON where we've got key, content, and value fix the bike, and that posts that up just the same way. Once you're working in JavaScript on the server, all you're saying is body.content on the request. So next one is, for no particular reason, we're just going to post up a string with the number 800 in it. Now, I would ask you to guess, but you can probably guess. You're just going to see the number 800. There we go. So what would happen if I was to strip off these quote marks from around the 800 here? What would anyone guess would happen? We've changed it now from a string to a number.
Same.
What's that, sorry?
I'm guessing same. Maybe the same.
It'll be the same. You'd hope so, wouldn't you? You'd think. What's that? 500 error. That would be reasonable, right? It's expecting a string payload and what's the I can't remember the error code for invalid content there, but I always Google them. But so we got a lot of A's back, and if we keep doing this, we might see some other stuff here. In fact, if I remember correctly, we've got something on. Yeah, let's just keep doing it and we might get lucky. It never works for me when I want it to. Just going to use the website a bit more and see if we can make it do what I want it to do. I'm going to try putting a bigger number in here because I believe this is going to give us a lot more data back. Okay, so we've got a lot of A's now. What we should be seeing here, and I'm afraid we might not be seeing it today, is some memory. Now, the way that memory allocated, and it also might have differed with my Node version potentially since the last time I gave this talk, but we should be seeing some uninitialized memory. So what this means is that whatever was previously in that memory is there. So whatever's been happening on that server, it's been using some data. It might be a completely unrelated process. It doesn't have to be the Node process. It's just grabbing some data, some blank space, except it hasn't been wiped out. It's more efficient to just write over the space than it is to first of all erase that space and then put some more data onto it. So it's pretty common when you're working with buffers to have uninitialized memory, but it's quite vulnerable when you're returning it down the pipe. So this is now able to access the memory. So things that are in memory might be your secrets, even if they weren't stored on disk, because you've almost always put them into memory in order to access them regardless of how they get there. So that's why this one can be slightly concerning. What was I going to do next? Oh, some Markdown. Markdown's fun. So yeah, we've got the ability to post some Markdown into our lovely to-do app. So if you put some stars around things, you can get some bold text. If you want to put a link in, that's totally valid. And what do you think is going to happen if I do a JavaScript alert 1? Luckily, the default syntax, so earlier we were saying about directory listing should be turned off by default. Well, for Markdown, it assumes that you're in an insecure environment, so by default it's sanitizing input. You need to actually configure it if you don't want sanitization, which means that like if you trust your content and you want it to put up exactly the content you have, you can turn that sanitization off. But the default is that it's on, which trips people up the first time they find it out, but it's a good thing. It means you're secure by default. What we're doing here, what are we doing here? Like, can anyone recognize these characters? They're slightly different to the URL encoding that we saw earlier. What kind of encoding are we seeing here? Yeah, HTML, or HTML encoding, exactly, HTML entities these are. So they are equivalent to characters in HTML. So if you were to put that onto a web page, it would totally be the same as the last thing that I wrote. It would be displayed the same. But luckily for us, interestingly, the sanitization is slightly different here, because last time we got just a single bracket, now we get nothing at all. That's kind of more accurate. So it's catching them. So going one step further, and yeah, so this is the same as what we had before, but with the word this injected in between. So this here is an HTML entity, but this here is nothing. This isn't a valid HTML entity anymore. So what do you think is going to happen once you put the word this into the middle there? And it's not random that we're using the word this. Because in JavaScript, this is valid, but in HTML, browsers are pretty good at stripping out invalid things and coercing them into things that they recognize. So we got a link, and if we click on it, we get an alert. Now you're thinking, is that the worst they can do? Put an alert on my website, so be it. But obviously this is just an example. As soon as you've got JavaScript in the browser, you've got access to whatever the user has in their session. So cookies, for example, are there, ready to be accessed in JavaScript, and you can AJAX them off to whichever website you want to. Once you've got someone's session, you can be them. You can impersonate them. You can travel around the website, see what you can get access to. So now somebody is impersonating somebody else, and they can gather their data or change things on their behalf. This is the kind of technique that people would use to get access to someone's Twitter account if they weren't really hot on this stuff, you know. So that's why we care about that one. So I do want to get this website working again. I'm going to drop off the Wi-Fi and come back online again and see if that does the trick.
Use my laptop.
Or we can do that. Or I can edit my host file. Hey, look what I did. I did break it. Interesting that it was working until just now. Yeah. Maybe the staging environment on Akamai was up until just now. Okay, good. So we're back. So I've shown you a lot of vulnerabilities and I've made you very scared, but there are some real easy solutions. So you can just, so if we go back to that ST vulnerability, you can see here that we're at version 0.24, and actually, if we updated to just version 0.25, we would fix that vulnerability. So really easy fix there. If I go and click on this button here, and this is a little bit of a plug, I'm just showing you an example of a tool you can use. This is about to open a fix PR on GitHub, because I've just pulled this in from GitHub, and it's going to fix all these vulnerabilities. Some of them can only be fixed in some places, so that's what we call a partial fix, and some of them are actually being patched as well. So I'll show you how that works. Because one of the things we were saying earlier is if a package is unmaintained, what do you do about it? You could try and not use that package, of course you could, but sometimes that's difficult, especially when we've all got a lot of other things we're trying to do in our daily work. So what we've done is for most common packages, we've written our own patches, and they're very minimal file diffs, basically. You can read them yourself, and they will find that vulnerability and wrap around it with some escaping or something like that that will basically sanitize and check for the thing that should have been there in the first place. So it takes a little while. It's just creating a new pull request. And if we have a look here at the files changed, you can see that a lot of these dependencies, so if we find st, there we go. So it's actually gone from 0.24 to 1.22. So we've got up to a new version. The reason why we had to do a major version bump there, we prefer not to, is because ST is actually multiple times vulnerable, and we needed to get rid of as many vulnerabilities as possible. So the lowest common version that has no vulnerabilities is 1.22. That's why that's happening. Anytime we're doing that, we're going to tell you about it. So you can see here which ones have a potentially breaking change, and just hopefully you have a test suite, hopefully it's going to pass and you'll know if you're good to go. But this is how you can start to get rid of vulnerabilities. I wanted to show you also those patches. So these are what patches look like, and it's basically as part of your npm install, it's going to apply a patch to these particular dependencies and make them not vulnerable anymore. So let's go back to the slides now. So I do need to give a disclaimer here. It's illegal to hack websites, so please don't use the knowledge I've just given you to actually do anything illegal. I'm really trying to educate everyone about what not to do and how to, especially with the code you're writing, how to make yourself less vulnerable. Exactly. So one of the things you can do is address known vulnerabilities in your dependencies. Remember that a known vulnerability is something that's out in the wild, so that's the ones to go after first. And it's super easy to do the dependencies stuff compared to your own code. There are tools that do static analysis and can try to understand what might be vulnerable in your code, but they're not super accurate. Whereas known vulnerabilities and dependencies is a known entity. So we can be super accurate, and we can just give you some advice on how to remediate as well. Find the issues, fix the issues, and prevent new vulnerabilities being added. Remember that code isn't static. You've got developers. You'll want something in your build pipeline, your pull requests, that's validating that they haven't just added a vulnerable package. And the other thing is that vulnerabilities can be found over time. So even if you're not vulnerable today, even if your code doesn't change, tomorrow we might discover a new vulnerability. So those are the things. Open source is awesome. Please enjoy responsibly. And we're hiring. Another plug. So we are growing rapidly. We will always have new positions popping up from time to time. So if you're interested in working on open source and security, get in touch. Thanks.